10 mistakes hardware startups make and how you can avoid them. If you're building a hardware startup, there's a high chance you've already made at least one of these mistakes. And right now, the worst part is, most of them don't show up until you've already burned a lot of time, money, and momentum. In this video, I'm going to walk you through the 10 most common mistakes hardware startups make and how you can avoid them. Hardware is fundamentally different from software in terms of development. You're not just writing code, you're dealing with engineering, prototyping, manufacturing, and often regulatory approvals as well. That means mistakes early on can be incredibly expensive later on. But here's the good news. Most of these mistakes are predictable and they're avoidable if you understand the risks and plan effectively in advance. Almost every hardware startup problem comes down to three types of risks. Technical risk. Can you actually build it? Commercial risk, will people actually buy it? And regulatory risk, can you legally sell it? The goal isn't to eliminate risk, it's to reduce the biggest risks first. So let's now talk about the mistakes. So mistake number one, starting with a prototype too early. This is probably the most common mistake people make. Building a prototype feels like you're making lots of progress, but if you haven't answered key questions like whether customers actually want to buy your product or whether it can be manufactured, you'll end up designing it again and again. Instead, you should validate the concept first. You can run simple proof of concept tests before committing to designing and developing a full prototype. Mistake number two, solving a problem that nobody actually cares about except yourself. You might think your idea is brilliant, but if the problem isn't painful or frequent, people just won't pay for it. So you need to go and talk to real users first. Understand how they currently solve a problem and whether they even care about your solution. Mistake number three, ignoring manufacturing early. A prototype that works in a lab doesn't mean it can be mass produced. For example, designing something for 3D printing might be completely different, might need a complete redesign for injection molding and for mass production. So instead, you need to think about manufacturing from day one, design with scale in mind. Mistake number four, underestimating the costs of development. Hardware development does cost money. It's not inexpensive. You're paying for engineering, prototyping, tooling, certification, supply chains, and stock. Instead, break development into stages and estimate costs progressively. Don't try and do it all up at front. It's never right. Mistake number five, ignoring regulatory requirements. Some products need certification before they can be sold, like electronics or medical devices. If you discover this too late, you might have developed a product that just will never meet those requirements and you'll need to redesign everything. So instead, identify the regulatory requirements early in the process. Mistake number six, over-engineering early prototypes. Many founders try to build something that looks like a finished product, but early prototypes aren't all about looks, they're about learning. Instead, make sure your functionality is valuable, make sure it works, prove a system works first before you invest too much into your prototype. Mistake number seven, trying to solve everything at once. Hardware systems are complex, and trying to solve all challenges simultaneously slows everything down. Instead, break the problem up into smaller parts and validate each of those parts first before you put it all together. Mistake number eight, failing to validate market demand. Just because you build it doesn't mean people are going to buy it. Instead, you need to test demand as early as possible in the process. You can do that with interviews, you can use visuals, or even take some pre-orders, register interest, however that's possible, but it's really important to understand, will people actually buy the product that you're designing? Mistake number nine, not protecting intellectual property. Not every product needs patenting, but ignoring IP completely can create lots of problems later. Imagine developing your product and then finding out someone else has a patent on it after you've spent all this time and money developing it. Instead of doing that, make sure you consider patents early. Have a look, see what's out there, and make sure you have clear space to operate. And if you can, get a patent for yourself too. Mistake number 10, expecting hardware to move like software. Hardware takes time. You need to design, test, manufacture, and often certify before you launch it. You can't do it all in 1 week. It takes time. Set realistic timelines and follow a structured process to get to the end. So here's the big takeaway. Most failures don't happen because of bad ideas. They happen because of a bad process. Successful hardware startups follow a structured development path, and that can involve an exploration stage, a proof of concept stage, a prototype stage, production preparation, and launch. Each stage progressively reduces the risk before you go and invest more. And at the end of the day, most of these mistakes come from the same thing, moving too fast without reducing the risk first. And that's why we've developed the Boost method. It's a structured but flexible product development process designed to test your product's viability and market fit at every stage of the way. So instead of jumping straight into building, you start by validating the fundamentals, both technically and commercially, before you go and build something. Each stage is designed to remove uncertainty before you invest more. That means fewer surprises, less rework, and a much higher chance of actually launching a successful product. Because building a great product isn't just about engineering, it's about making sure you're building the right product in the first place. At the end of the day, most of these mistakes come from the same thing, moving too fast without reducing risks first. That's why we've developed the Boost method. It's a structured but flexible product development process which is designed to test your product's viability and market fit at each stage. Instead of jumping straight into building something, you start by validating those core fundamentals, both technically and commercially. Then you prove the technology, test the market, build and refine prototypes, and only then do you move into manufacturing.